Yeah, welcome back, everyone. This is Imperial Lauben. We shall view artificial intelligence by exploring the fundamentals and interdisciplinary connections, bridging Alison course content with data mining, cognitive science, artificial intelligence philosophy, and Retina artificial intelligence for eye disease detection. Enjoy the ride. As part of the introduction presentation scope, we shall be covering data mining, cognitive science, artificial intelligence philosophy, and we shall have a healthcare app, which is Retina artificial intelligence for eye disease detection. So in our first module, we shall be covering artificial intelligence history, the trends and its future. So we begin by looking at the definition of artificial intelligence, how it is defined as simulation of human intelligence in machines programmed to think and learn like humans. It normally covers various techniques that really require human intelligence. Then we look at various aspects of it from historical development, the current trends, and future prospects. Amongst current trends, we see how currently deep learning, large language modules like ChatGTP, computer vision, then how we are having reinforcement learning and AI being integrated across various domains. Uh, then we move to module 2 and 3, which covers problem solving in artificial intelligence, normally covering such algorithms. Then we are seeing how problem solving involves three states, which the first one being defining the search space, which is problem state. Then the second one being identifying the goal or stating the goal. Lastly, being actions that normally that are used to transfer between states, like to reach the goal. So we can see we have various such algorithms, of which we have uninformed search and informed search. And you find by uninformed search, it blindly explores all options to reach the goal state. And you find when it comes to informed search, you find like it has additional information or it uses heuristics to make intelligent decisions to reach the goal state. And those are various examples for each algorithm. So in module 4 and 5, we shall be covering knowledge representation and reasoning. So when it comes to knowledge representation in artificial intelligence, we start by defining how information is organized and stored in a system, to really facilitate intelligent searching or behavior, which normally involves various steps. One of them is transforming facts, applying rules, and establishing relationships about the word in a machine readable format. So for the case of our project, which is Retina AI, it really means organizing data that is normally on retina features, disease markers, and diagnostic criteria, to make such wise decisions. So we also look at reasoning. We see how reasoning is built upon knowledge representation, which allows our AI model to make conclusions, to make judgments, and be able to solve problems using the stored information. So we move to module 6, which covers reasoning and uncertainty. So we see how our Retina AI is going to be embracing incomplete information. Since for the first time when problems for the first time occur in the domain, there is always less precise data. There is always less data known about it. But with the help of AI, we are able, even without inadequate data, we are able to make judgments, we are able to make conclusions. Then we also apply probabilistic methods or approaches. These are normally based on Bayesian theorem, and we are able to assign likelihoods to outcomes, and we are able to come up with better estimations or approximations to the outcomes. Then we also see how Retina AI is very adaptive in diagnosing. So we see how uncertainty is really inherent in early disease stages. But with the usage of advanced algorithm, we are used to weigh evidence, and we are able to assess probabilities of different diagnoses, and we are able to provide better accurate and confidence scores. With the help of which really reflect like best Christians' refined judgment about these ambiguous cases. Then when it comes to module 7, we are tackling planning and decision making. We see how we are able to integrate planning and decision making in our Retina AI for eye disease detection. Then we are able to see how our Retina AI is able to utilize goal-directed action sequencing to guide steps for eye diseases. We are able to use data mining, which really helps us to discover the insights, the patterns, which really help in optimizing plans to achieve better diagnosis outcomes. Then we look at the key features. We look at one of the major features, which is data-driven planning, where we are able to identify the normal patterns in patient data to make informed action decisions or plans, which really mimic body kinesthetic intelligence in sequencing regarding Gardner's 8 types of intelligence. Then we also look at optimal decision making. We see how AI is able to balance prediction with the risks, able to make optimized patient outcomes despite medical risks. Then we are able to also look at philosophical roots, where we are able to address AI's frame problem, whereby we are able to select like the relevant conditions that apply to the situation while leaving the less the less upright while minimizing risks or consequences of making such decisions instead of exploring every choice. Then we look at module 8, which is the introduction to machine learning. So we see how artificial intelligence allows systems to learn and improve themselves from experience without being explicitly programmed. We look at the core concepts of machine learning, and data-driven. They normally learn from data rather than following predefined instructions or rules. Then they normally improve from experience or as they interact with more data. Then they are also aimed at making accurate predictions when it comes to new and seen data, basing on the learned patterns from the training data set. Then we see the subsets of the different machine learning techniques, supervised learning, unsupervised learning, and reinforcement learning. So regarding our project, we can see how supervised learning really trains models on labeled retinal image datasets to clarify diseases. Then when it comes to unsupervised learning, we see how it explores unlabeled data, discovering hidden patterns in retina scans that may reveal new disease markers. So we look at the role of dataset in model training. Yeah, we see how we are supposed to leverage high quality annotated retinal datasets, like really to train these models. So you find like we have a dataset of labeled images, which normally provide a ground truth, yeah, for our training model. Meanwhile, we also have unlabeled datasets that are used to train our unsupervised algorithms that are used to discover underlying natural insights like within rating of features, potentially revealing hidden insights. We look at how data mining is done in our retinal AI for eye disease detection. So we see data mining. It is all about discovering hidden patterns or insights from complex data set. So we see how we are able to extract patterns and insights from our complex retinal imaging datasets. Yeah, using labeled and unlabeled data. So we are able to train our AI models to be able, like, to increase their level of accuracy for better eye disease detection. Then we look at how supervised learning is being done in our retinal AI for eye disease detections. Yeah, so here we utilize annotated retinal images with expert labeled diagnoses, and we are able to apply classification models that are able to categorize these retinal images into various disease stages, which allows like better identification of conditions, yeah, like at an early stage, like diabetic retinopathy and glaucoma and age-related macular degeneration. Yeah, why we are able to utilize regression, yeah, to really estimate continuous disease severity scores, yeah, allowing us to have find assessment and monitoring of disease progression over time. So we look at how unsupervised learning is being done in retinal artificial AI. So you find these models, they are able to learn from unlabeled data. So unlabeled data and this various data, it normally constitutes of reasons, homologies, and reason with clinical diagnoses provided by specialists. So mostly it is always an automated process. So we again move to the next slide, which explores types of intelligence in Retina AI. We are able to explore the 8 types of intelligence regarding Gardiner. So one of them is logical mathematical intelligence, yeah, which really relies on pattern recognition, like within complex data structures. Yeah, so like retaining to retinal retinal constituents or structures. So we also have naturalistic intelligence, yeah, which is inspired by environmental analysis. Then we explore another kind of intelligence that is intuitive, yeah, that is really, yeah, inspired by learned experience from datasets. So we look at the computational artificial intelligence philosophies, which cover Turing test and Chinese room. So we are able to emulate our rating artificial intelligence working as a weak AI, simulating like intelligent behavior for specific tasks. Yeah, really, as a Turing test, which really correlates with Chinese room argument. Yeah, which really practically emphasizes like problem solving within its domain rather than aiming for human level cognition or consciousness. So we see the conditions the like of Turing test that was initiated by Alan Turing in 1950 of that really proposes whether artificial intelligence really can think like a human, and we are able to relate artificial intelligence ability to perform certain specific tasks. Then we look at also Chinese room argument that was formulated in 1980, yeah, which really brings out symbol manipulation, not implying understanding or human consciousness. And it really supports the view of the current artificial intelligence like our Retina AI for eye disease detection, yeah, which really operates without human consciousness or understanding. So we look at the comparison. We look at the debate of superhuman intelligence debate. We start by analyzing analytical power of artificial intelligence, how it is able to process huge amounts of retinal data sets, able to identify patterns beyond human capacity, which really accelerates diagnosis and research. Then we also see how humans are able to have better clinical judgment and better ethical decision making and empathetic patient care that AI can't really like exhibit. Then we also look at the need of having collaboration between humans and AI and being able to use AI as a tool, yeah, to complement diagnosis, yeah, to have better outcome. Yeah, then in our conclusion, we are able to view key insights from Alison AI course, which is Fundamentals of Artificial Intelligence, in terms of in levels of interdisciplinary nature, its practical applications, from data mining to natural language processing, then to complex problem-solving domains. Then we also come to philosophical questions, yeah, which really highlight intelligence and consciousness and relationship between humans and machines. Uh, yeah, through concepts like Turing test and Chinese room argument. Yeah, really, thanks for listening. Yeah, thank you.